back. It's 6.2 day one. We're going to start looking at compound interest. And in the words of Albert Einstein, compound interest is the eighth wonder of the world, because he who understands it will earn it, and he who does not will pay it. And that is so true in this world of credit cards and people buying things on loans and so forth. So if you understand how interest works, you will end up earning it. If you don't, you will end up dearly paying for it. So we're going to take a look at compound interest today. So remember our exponential growth formula. We have our final amount, A, here, our initial amount here, and then our rate of increase here, which is our growth or decay factor, and our time periods up here in T, okay? Well, compound interest kind of follows the same thing, except we have a couple different extra values here. So when interest is paid monthly, the interest is earned after the first month becomes part of the new principal for the second month, and so it kind of perpetuates itself. Interest is earned on interest already earned, okay? And so this is called compounding interest because the amount kind of compounds on each other. So this compound interest formula is an exponential model that is used to calculate the value of an investment when interest is compounded. So we kind of see it's a kind of a very similar formula to our decay and growth model. We have our amount, our final amount here. Our principal is like, our initial amount. That's called a principal amount. And then we have our annual rate here. The only difference is we take 1 plus or minus, but we usually use 1 plus our interest rate divided by the number of times of year it's compounded. So sometimes it can be compounded monthly, sometimes daily, sometimes quarterly, which means 12 divided by 4, which would be 3, right? Quarterly. Sometimes continuously. We'll talk about that next time we meet. And then it's raised to the power of years multiplied by how many times a year it's compounded. So if it's, semi-annually, it'd be 2 times a year. So we take the number of years times 2, because it's how many times it's compounded over, a course of 10 years or whatever. Okay. So that's our general formula right here. Okay. So just an example here, Tamira invests $5,000 in an account. It pays 4% annual interest. So how much will there be in an account after 3 years if the interest is compounded annually, semi-annually, quarterly, or monthly? Okay, so if you take a look at this here, our formula right here, our initial principal is 5,000. That's what she put down first. 1 plus, and we take that interest rate of 0.04 in decimal form, divide it by 1 because we're doing annually, so just once a year, raised to the power of 3 years times just 1 because we're only compounding 1 time in the year. Okay, and so that's my end there. I gotta get my pen here. So this is how much money she has after 3 years. Okay, semi-annually. So now we're doing it twice a year. So our principal amount is the same, but this time we're going to take 0.04 divided by 2, and that's going to give us 0.02. So after 2 years, we're going to take 2% and add that to our $5,000. Then it's raised to the power of 3 times 2, because really we're going to, over 3 years, compound it 6 times. We're going to calculate that interest 6 times instead of 3, because we're doing it twice a year. Okay, so she'll end up getting $5,630.81. So notice it's a little bit bigger than this time. She gets a little bit more money by compounding it twice a year instead of once a year. Okay, quarterly, she puts in $5,000. She's going to get 4% divided by 4 this time because it's 4 times a year. Okay, and so then it's going to be raised to the power of 3. So now it's like every 3 months, right? So 3 times 4 is going to give you 12 times over a 3-year period. Okay, so notice at this time now she's going to get $5,634.13. So even a little bit more money. Okay, monthly. So now she's going to compound it 12 times in the year. So we're going to take that 4% and divide it by 12, and then raise the power of 3 times 12. So we're going to be compounding that interest and calculating interest 36 times over the course of 3 years. Okay, her final amount will be $5,636.36. So it's even greater. So notice that, however, the number of compounding periods increases, the amount in the account also increases. So the more you can compound that interest, the better off you're gonna, the more money you're gonna earn. Okay, so now let's actually calculate some amounts. So you invest $1,000 into an account that earns 2% annual interest, compounded quarterly. Okay, so here's my quarterly. We have our principal amount. We have 2% annual interest. What is the value after 20 years? So those are all kind of my key values there. Okay, so we have our total amount is going to be my principal. So maybe I'll color code some of these things. So this is my principal. We're investing $1,000. Okay. And then we're going to go 1 plus, and now we're going to take my interest rate, and I'll just leave that as red. We're going to write this as a decimal, so it's going to be 0.02. All right. Divided by, and then we're going to take our quarterly right here. Quarterly. So that's divided by 4. Okay. And then we're going to raise that to, again, 4, because that's how many times we're compounding it, times our time in years. And so our time in years is going to be 20. So we're going to multiply that by 20. Okay. So we're going to have our A equals 1,000 times 1 plus, and if you take 0.02 divided by 4, you're going to get 0.005. And you can put that in a calculator if you want, or you can just trust me. Okay. 4 times 20 is 80. So now our final is going to be 1,000 times 1.005 to the 80th. Now that should look really familiar with our growth and decay formulas, right? We have our growth factor of 1.005. Our time is 80 right there. Okay, so I'll go ahead and put this in the calculator now so you can kind of see what this looks like. So I have $1,000 times our 1.005. We're going to raise that to 80. That's 80 total compounds over 4 years, or 20 years, excuse me. So 1490, 34, right? So amount is going to be about 1490, 34. That's how much is going to be in the account after those 20 years. Okay, so you're going to earn about $490 over 20 years. So not a whole lot of money, 2% interest, but a little bit, right? Free money. Okay. Okay, so this time it's saying how much must you deposit? So how much are you going to actually, that's P, how much you're going to deposit? We don't know. In an account that's going to pay 3% interest. Okay, so here's that. We're going to go our 3% interest, change colors, compounded monthly. This time to have a balance of $2,000 after 2 years. And let's make our 2 years blue. Okay, after 2 years. Okay. So this time we want a balance. So that's what our A is going to be. Our A is going to be $2,000. We want our balance to be that much. So how much are we going to actually have to deposit in here? My P. Okay. Times 1 plus, and my interest rate is going to be 0.03. Okay. Divided by monthly, so we're going to be 12 times, right? Divided by 12, because we're going to do it monthly, 12 times in a year. 12 times in a year. And then we're going to raise it to, again, 12 times how many years. We're going to be going over 2 years. So we're going to be doing 24 times over 20 years, compounding 24 times. Okay? So 2,000, whoops, I didn't mean to do blue. Let's get our black out here. 2,000, oh well, we'll go with dark blue, equals P times 1 plus, and then 0.03 divided by 12 is going to give me 0.0025. And then to the 24th power. So 2,000 equals P 1.0025 to the 24th. Okay. Now here I'm just going to go ahead and divide. Solve for P. I'm just going to go ahead and divide by 1.0025 to the 24th. 1.0025 to the 24th. Okay, and that will give me a principal value that I need a deposit of. So let's figure out what that is. 2,000 divided by, and I need to put parentheses in here. So I'm going to go 1.0025 to the 24th power and close my parentheses. So about 1,883.67. About 1,883.67 is what I need to initially put in my account. So about $1,883 or $84, somewhere around there. I need to put in order to earn $2,000 after 2 years. Okay. All right. So now you try it. Maybe pause the video. See if you can figure this out. $3,000 is invested in an account that earns 3% annual interest compounded monthly. What is the value after 10 years? Okay, so we want to know how much is going to be in our account. We initially put in $3,000. 1 plus my interest rate is 3, so I'm going to put 0.03 divided by monthly is going to be 12. Okay, So it's going to be 12 again times 10 over 10 years. So amount is going to be 3,000 times 1 plus, and I believe that's going to be 0.0025 again, 0.0025 again to 120 this time. So amount is going to be 3,000, 1.0025 to the 120. So I need to see in your work, I need to see your setup at the very least, okay? I need to see how you set it up. Don't just stick things in a calculator. If I can't see it, I can't see your head, I can't give you credit, okay? So 3,000 times 1.0025 to the 120th power leaves me with 4,048 and 6 cents. 4,048 and 6 cents. Whoops, 6 cents. There you go. As how much we have in our account after that 10 years. Okay, so we've made over $1,000. That's pretty good. Even just a percent increase makes a big difference in how much money you earn. Okay. All right, so you have an Excel in Google Classroom, and if you have any questions, let me know, and I will see you all soon. Thanks. Bye-bye.